We have spent some time looking at objects in R, most recently data structures. Now it's time to turn our attention to functions. Here again is the quote by John Chambers, creator of the S programming language that R was based on. To understand computations in R, two slogans are helpful. Everything that exists is an object. Everything that happens is a function call. So now we're going to look at function calls. A function is just a set of statements that accomplish a specific task. You can think of a function like an R script. It has a specific purpose, and every time we run it, it accomplishes the same purpose. Functions are objects. The operators that we have looked at, like the plus sign, or the mod, or a Boolean operator to check for equality, those are all functions. No surprise, functions are functions. R has built-in base functions, but what's even more exciting is that R can be extended with packages that include more functions. So every individual's implementation of R can be a little bit different in terms of what functions are available to them, depending on what packages they have installed. Users can define their own functions. Before too long, you will learn how to define your own functions. Now there are four main components to every function. First is the function name. Let's look at the mean function as an example. As you know, if I use the question mark in front of mean, I can get information about the mean and about the mean function. The mean is a function. Note the description, generic function. If I get the class, it confirms that the class for mean is function. Given that functions are objects, we can assign functions to other objects. Here I'm assigning the mean to superdupermean. Note that the class of superdupermean is function. The second function component is an argument. You can have multiple arguments, but you also could have no arguments. These are not required, but they're very common. Let's look at the characteristics of function arguments. The formal arguments are a property of the function, but actual arguments are used to call a function and can vary. Look again at our example of the mean. Notice in the help section, it lists the potential arguments for the mean. These are formal arguments. So first is an R object, then is the fraction of observations to be trimmed, then is a logical value. So we have an object, we have a number, we have a logical. The placeholders for these are x, trim, and na.rm. These are referred to as formal arguments. But now when I actually send an argument to the mean, I'm going to do that now. First, I'm going to create my data, which is going to be a vector. So of course, if I look at the class of my data, it's numeric, indicating it's a numeric vector. Now I'm going to send my data to the function mean. This is an actual argument, my data. So the formal argument is the placeholder indicating that we need to send an object. The actual argument is what we're sending. So I'm going to send my data to the mean function, and I get out the mean of 5.3. Similarly, since I saved the mean into super-duper mean, I can use super-duper mean for my data and also get 5.3. The formal argument was the placeholder x. The actual argument was the vector of numbers that we sent to the mean. Arguments can have default values. Note that we have two listed optional arguments for the mean. They're listed here in the help section as trim and na.rm. Notice that trim is equal to 0 and na.rm is equal to false. That is what they're initially set to, so these are the defaults. So when I ran mean for my data back here on line 48, the trim was an optional argument set to 0, and na.rm was an optional argument set to false, meaning that since I did not actually use those arguments, they're still there. It's optional for me to indicate something different. They're still there, but trim equals 0 and na.rm equals false. So if I were to add to mean trim equals 0 and na.rm equals false, I'm going to get exactly the same thing, 5.3, that I got before when I didn't have them in. That's what we mean by them being optional, and that's what we mean by them having default values that are used whenever you do not insert the optional arguments. Now let's look at actually changing those optional arguments. Let's use the mean function again, but this time we're going to trim the lowest and highest 10% of the values. Notice what it says in the help about trim. It's the fraction of observations to be trimmed from each end of x before the mean is computed. So, if I were to use mean, my data, I'm still using this vector up here, but now I'm going to trim 10%. Now instead of 5.3, I get 5. What did it do? It trimmed the 2 from one end and the 11 from the other end. There are 10 values here. So 10% of 10 is 1, so it took 1 from each end. Notice that if I got the mean of this vector here, where I took out the 2 from the left end and the 11 from the right end, I get the exact same thing. The purpose of trimming is to remove outliers when calculating the mean. So it actually makes the mean more robust to the possibility of outliers when you use the trim argument. Arguments can be called by name or position. It is good practice to call required arguments by position. It's common practice to call optional arguments by name. When I used trim before, I put in my data as the required. I put in 0.1 without calling it trim, but I knew that would trim because of the order in which the arguments are listed. Look in the help section. X is the object you need to send that you want the mean of. Trim is next. So by putting 0.1 after the object, I knew it was going to trim. But if I want to make that more explicit, I can do what I've done down here on line 65. I can have the mean of x equals my data and trim equals 0.1, and I still get the value of 5. Now this next example is not good practice, but it works, and I want to show you it works, but I'm not recommending you do this. In fact, I recommend you do not do this. By convention, we call mandatory arguments first before the optional arguments. Here's an example to show that this is not required. So notice I have the trim equals 0.1 first and the x equals my data. Now, since I'm doing these in reverse order, I have to name them. If you don't name them, then the mean function is going to expect to get x and then trim next. And then if you have it, na.rm third. So let's go ahead and run this and show that it still works, but not good practice. Don't do it. Suppose we have some missing data. Here I'm creating my next data, a vector, again numeric, but it has some missing values indicated by the NA. If I try to get the mean of my next data, I get NA. Why? Look at what it says for na.rm, a logical value indicating whether NA values should be stripped before computation. And notice the default is false, meaning don't take out the missing. So what happens when we try to calculate the mean of these, since we're not taking out the missing, it does not know how to calculate a mean. How would you calculate a mean of 2 and 2 and missing and 3? What would you do? 2 plus 2 plus missing plus 3? No, there is no way to calculate this. And so that's why we got NA. But now if I change this argument, na.rm equals true, and note I have to put the na.rm here because if I don't, it's going to think that I'm trimming because I'm using the second argument, but really in the formal list of arguments, it's the third argument, so I have to use na.rm equals true. Now I will get the mean of all the numbers not counting the missing values. So we get 5.75. Ellipses, or our users like to call them 3 dots, are placeholders for additional pass-through arguments. So let's look at the 3 dots. Here in the mean arguments, we have x, an object, we have trim, we have na.rm equals false, and then we have these things that look like ellipses that people who work with R always refer to as 3 dots. So we'll call them 3 dots as well. The 3 dots represent further arguments that are passed to or from other methods. Now what happens when I put in additional arguments? Let's try it. So here I have mean, my data, no trimming. I'm going to remove any missing values with na.rm equals true, and then I'm putting in a number 7 and a logical false, which is not even listed here. That's in place of the 3 dots. What happens when I do this? I get 5.3. Nothing extra happens. It didn't give me a warning. It didn't give me an error message. It was content to take those. I knew that would happen. Why? Because in the documentation, it gave me the 3 dots, which means that I can put in extra arguments. What's that all about? Why can we put in extra arguments? We'll look at that in the next video, in which we look at the next component of a function, the body of the function.